guys, in this video I'm going to teach you about goal 3, which is factorizing a difference of two squares. So a difference of two squares is a special type of algebraic expression in which the two terms in the expression are both perfect squares. So if you remember, a perfect square is a number that you can take the square root of it and get a rational number. So one example of a perfect square is 4. Because when you take the square root of 4, you get 2. 2 multiplied by itself is 4. Another example of a perfect square is 25. When I take the square root of 25, I get 5. 5 times 5 is 25. Perfect square variables are numbers that have an even exponent. So I can take the perfect square, or the square root, of x squared, and that's going to give me x. X times x is x squared. I can also take the square root of x to the power of 4. That's going to give me x squared. X squared multiplied by x squared is x to the power of 4. You guys will mostly be working with perfect square whole numbers and perfect square variables with an exponent of 2. So difference of two squares, each term in the expression, each of the two terms, is a perfect square. Not just one, but both are perfect squares. And those two terms are always separated by a subtraction sign. So difference of two squares is two terms. Each term is a perfect square, and those two terms are separated by a subtraction sign. So if you look at the examples here, I have a squared minus b squared. A squared is a perfect square. I can take the square root and get a. B squared is a perfect square. I can take the square root and get b. And there's a subtraction sign here. If I look at the next example, I have 4a squared. My coefficient is a perfect square, 4, and a squared is a perfect square. 16b squared, I have a coefficient that's a perfect square, 16, and my variable is also a perfect square, b squared, and it's really important that those are separated by a subtraction sign. So the reason that we take the time to learn about perfect squares is that they're really easy to factorize because they all follow the same pattern. So up until this point, we've factorized by taking out a common term. Sometimes that's not possible. If I look at a squared minus b squared in our examples, there's no common term there. There's no common factor that we can take out. But there is a way to factorize that and make it more simple. And the way that we do that is by following this pattern. So every difference of two squares question can be factorized into two brackets. Each bracket contains the square root of each term. So if I look at this, my first term is a squared. The square root of a squared is a, and it appears first in each of these two brackets. The square root of b squared is b, and it appears second in each of these brackets. Then I just write two different signs in the brackets. One of my brackets has a negative sign, and one of my brackets has a positive sign. And all questions follow this exact same pattern. We'll do some examples in a second. But I'll show you why that's the case. So if I work backwards here, and I have our factored form, a minus b onto a plus b. And I want to FOIL that out to check my work and make sure that I get my original expression here. So if I FOIL, I've got a multiplied by a. That gives me a squared. I've got a multiplied by b. That gives me positive ab. In the middle here, I've got negative b multiplied by a, which gives me negative ba, or we would probably write it in alphabetical order, negative ab. And then finally, I've got negative b multiplied by b, which gives me negative b squared. If I look at ways to simplify this long expression, I have like terms in the middle here, and this is always going to be the case. I have a positive AB minus AB. So if I look at AB subtract AB, that gives me 0. Those are going to cancel out just like they would if we were doing substitution in our last unit. And what that leaves me with is a squared minus b squared, which is what our original function was, or expression was, up here. So this is just a proof to show you that this pattern is always true. So if I take a look at doing an example on the next page, I'm looking at fully factoring 36x squared, subtract 9. So the first step is to find the square root of each term. So my first term here is 36x squared. If I look for the square root of 36x squared, the square root of 36 is 6. 6 multiplied by 6 is 36. The square root of x squared is x. X multiplied by itself is x squared. If I look at my second term here, I've got 9, and we don't care about the negative for now. We know that every single difference of two squares has a negative, so we're not going to worry about that. But if I look at the square root of 9, that gives me 3. So I've taken my square roots of each term there. In step 2, it says using two brackets, write the square roots separated first by an addition sign, then by a negative sign. So what that looks like is, here are my two brackets. And I've got 6x plus 3, so there's my addition sign. And in my second bracket, I've got 6x minus 3. So I've got two brackets here. I'm writing my square roots of my terms in order, and then I'm separating them by a plus and by a minus. I could have easily written the negative here and the positive there. It doesn't matter what order we put the brackets in. Then I need to check my work by expanding. So I have 6x plus 3 multiplied by 6x subtract 3, and I want to expand this out. If I'm using FOIL, 6x times 6x is 36x squared. 6x multiplied by negative 3 is negative 18x. Positive 3 multiplied by 6x is positive 18x. And 3 multiplied by negative 3 is negative 9. I take a look at my like terms here that I'm always going to have in the middle of my equation if I've done it correctly. Negative 18x plus 18x, those are going to cancel out, and I'm left with 36x squared, oops, I forgot my 6, 36x squared minus 9, which is what I started with up here. So this is my fully factored form of the original expression. This is my answer. Here's another example. We have 9y squared minus 16. I want you to try this on your own. Pause the video and try this on your own, and then we'll move on, and I'll solve it for you. So I have 9y squared minus 16. My first step is to take the square root of each of my terms here. Square root of 9y squared is 3y. Square root of 16 is 4. My next step is to write those in two brackets, separated first by an addition sign, and then by a negative sign. So I've got 3y plus 4, and in my second bracket I've got 3y minus 4. My last step is to FOIL that out. So if I do first times first, 3y times 3y is 9y squared. 3y times negative 4 is negative 12y. 4 multiplied by 3y is positive 12y. And 4 multiplied by negative 4 is negative 16. As always, my middle terms are like terms, negative 12y plus 12y. Those cancel out and become 0. And I'm left with my original expression, negative y squared minus 16. So all this third step is doing is checking your work to make sure you get your original expression. This is your factored form. This is your final answer here. So this example is a little bit different. I want you to think about that for a second. Why is this example different? Hopefully you realize that this 3 is not a perfect square. I can't multiply two whole numbers or two rational numbers by themselves in order to get 3. So I'm going to use a trick here that we used in Skill 2, and I'm going to take out the highest common factor. If I didn't have a highest common factor here, this question wouldn't work. But if I look at the highest common factor between 3 and 12, I should recognize that my highest common factor there is 3. If you need to draw a factor tree to find that, that's totally fine. But my highest common factor there is 3. So if I factor that out, that's going to leave me with 3 multiplied by b squared subtract 4. So I factored out my highest common factor. And what that leaves for me inside these brackets is a perfect square. B squared is a perfect square, 4 is a perfect square, and they're subtracted by a negative sign, which means that I have that difference of two squares that's so easy to factor. So I'm going to concentrate on this bracket right here because it's a difference of squares. And I'm able to factor it further than just taking out a common factor. So if I have a difference of squares here, my first step, if you remember back to example, the other examples in skill 3, is to take the square root of my first term. So the square root of b squared is b. The square root of 4 is 2. I'm going to write those in brackets separated by a plus sign and then a negative sign. So b plus 2 multiplied by b minus 2. What I can't forget in these examples where I've taken out a common factor is to put the common factor in front of those brackets. So this should be my final answer, and I can check to make sure that's true. But this should be my final answer. 3 onto b plus 2 onto b minus 2. So if I want to check my work here, I've got 3 onto b plus 2 onto b subtract 2. I can either distribute that 3 into my first bracket first or FOIL first. I usually prefer to FOIL first, so I'm going to do that. So if I FOIL here, I'm going to keep my 3. And I'm going to have b times b, which is b squared. I'm going to have b multiplied by negative 2, which is negative 2b. 2 multiplied by b, which is positive 2b. And b multiplied by negative 2, which is negative 4. So my like terms in the middle are going to cancel out, as always. And I'm left with 3 onto b squared minus 4. Now if I distribute that 3 here, to get rid of my bracket finally, I'm going to have 3b squared minus 12. And that's what I started with up here. That was my original equation, or original expression, sorry. So that tells me that I've done it properly. Last example here. I want you to try this on your own before I solve it. I have x cubed y, subtract xy cubed. So try this on your own before. Pause the video and give it a try. And now I'll show you how to solve this. So the first thing we want to look for here is a common factor. And if I look at x cubed y minus xy cubed, if I break apart x cubed y, that's the same thing as x times x times x times y. And if I break apart xy cubed, that's the same thing as x times y times y times y. So if I'm looking for a common factor here that I could take out, I have an x here and an x here. I also have a y here and a y there. So when I remove that highest common factor, that xy, what's left in my brackets here from my first term is x squared. What's left in my brackets from my second term is y squared. And those were originally separated by a negative, so we're going to keep that negative there. Now I have a common factor out front and a difference of 2 squared, x squared minus y squared. So I'm looking for the square root of x squared, that gives me x. I'm looking for the square root of y squared, that gives me y. So my new expression is xy, my common factor stays out front, and then I've got x plus y coming from these square roots onto x minus y. And if I wanted to take the time to go ahead and expand that out, to FOIL it, I would see that I got the right answer. So if I FOIL this part, I'm going to get x squared minus xy plus xy minus y squared. And all of that is multiplied by xy. These middle terms are canceling out. So I now have xy multiplied by x squared subtract y squared. And when I FOIL that, distribute that through, I've got xy multiplied by x squared. That's going to give me x cubed y. We remember that from Unit 2. And then I've got xy multiplied by negative y squared. That's going to give me negative x y cubed, which was my original expression up here. So I know that this final answer, where I've taken out the common factor and then used difference of two squares factoring, is my final answer, and it's correct. So I'd like you to try the textbook questions that are written on the board now, not the ones in your workbook. Remember, I used the wrong edition of the textbook for that. But try the workbook, or questions that are written on the board, not in your workbook, and see how you do. Thanks, guys.